imagine in city environments, your mobile phone being used to relay data across the city itself. So the research I did in the Smart Dust video covered the work that I was doing with sensor networks, and that was little tiny devices that were low powered and distributed across an environment. And so that work I've continued to do actually. Very interestingly, the work that evolved from the work since that video, we did a piece of work out in digital agriculture with the vineyards in the south of England, in particular Ridgeview vineyard in the south of England in Kent. In that piece of work we were measuring soil moisture content, and we found that our radio, the communications radio, was doing a better job than our soil sensors. So we started to look into that, and that led us to the work that we're doing now, which is on radar sensing. Technology has evolved in different ways in the last 10 years. In 10 years, we've seen an increase in the use of machine learning AI in the kinds of systems that we're building. So we're pushing out that processing to those tiny devices. Those tiny devices have got smaller. For example, if you look at earbuds, earbuds have about 6 or 7 sensors inside that tiny thing in your ear, and there the edge compute on those, the learning on those is quite expansive compared to what it was 10 years ago, which means, as I predicted, all the computation will start moving out to the fog, out to the very edge. So at the moment I'm working on a piece of work that takes the communications network and makes it into a sensor. So it's the network as a sensor. And so what it's doing is taking the likes of Wi-Fi and measuring. What we do is we've built a little box that measures the reflection of Wi-Fi off, say, human skin or other things. And what we do is that's the sensor. We're measuring the individual, where they are, what they're doing. Joint sensing and communications is really exciting because we're making use of something that already exists, Wi-Fi or the telecommunications network, and we're applying it to something brand new, and it's not easy to do it. So it's a beautiful, juicy problem. And once we get it working, that is where it is able to sense different things in the environment, anything from humans to machines to bridges to anything really, and plants. I've applied it to plants and the growth of plants even. That means that we no longer need to have sensors placed out there. Now, when you think about that, the same energy that goes into these systems is going into the sensing, and the materials that we use for sensors are no longer needed. Therefore, this becomes a much more sustainable solution to sensing. So in the next 5 years' time, the work that I'm doing on joint sensing and networking will converge and be part of the 6G telecommunications initiative and strategy. So we're working a lot on that, and so in 5 years' time we should be able to roll out our first demonstrations of that, and in 10 years' time that should be the networks that everyone uses with their phones, with their the equivalent of Wi-Fi outside and so on. So this new 6G infrastructure is what I'll see in the future, and that will have joint sensing and communications. It was interesting in the old video, I tried to predict what would happen now, and things haven't changed that much since. So I'm going to go with things when we hit the 6G system, it'll just be improvements from there on. Now 6G brings super fast telecommunications. That means we'll see new applications that we can't do now out in the wild. And so I think that will be where the innovation will lie.